Jesse! Jesse, open up! Wake up, Jesse! Jesse, wake up! Jesse!
Jesus Christ, Mr. White.
Jesse!
What the heck? You could have just...
Jesse, do you understand why I'm here?
If you want the meth, it's in the...
No, Jesse! I need to know if you understand the process of photosynthesis.
What are you...
Jesse, quickly!
The light in the plant makes it grow.
No, Jesse! What are you, stupid? There's so much
Yo,
more-
what does this have to do with...
Jesse, I need you to listen to me. If we're gonna run this business successfully, you need to fully grasp the concept of photosynthesis. Do I make myself clear?
Crystal.
Alright, Jesse. You understand that leaves are made of spongy cells, and that within these cells are organelles called chloroplasts, correct? And in these chloroplasts are little discs called thylakoids, and when in a stack are called a granum. The thylakoid membrane separates the fluid inside the chloroplast called the lumen, and the outside fluid called the stroma. On the outside of the thylakoid membrane exist two different light-absorbing systems called Photosystem I and Photosystem II. Jesse! Jesse, are you following?
Yeah, jeez.
Now I bet you're wondering how exactly chloroplasts absorb the light in the first place. Well, it's because of specific pigments that absorb said light to be used in a different state of energy, such as chlorophyll A, chlorophyll B, xanthophylls, and carotenoids. Now we start this process in Photosystem II.
But Mr. White, why don't we start in Photosystem I?
Because, Jesse, Photosystem I was discovered before Photosystem II.
But why didn't they just rename...
Because that's how it is, Jesse. We can't change it now. Anyway, photons from the light excite the electrons of a chlorophyll molecule, which pass the energy along each other until it reaches a P680, and its electron pops off and gets carried away to the cytochrome complex. A region in Photosystem II called the oxygen evolving complex takes the electron holding water's molecule together and replaces the P680's electron. Afterward, the H2O changes into hydrogen and oxygen. The hydrogen is kept in the lumen, and the oxygen is released as waste.
Oh, so that's how plants create oxygen for us to use. Because they don't need oxygen.
No, Jesse! Plants still need oxygen for a process called cellular respiration. But that's a topic for another time. The cytochrome complex consumes the energy from the electron to put more hydrogen into the lumen from the stroma. Afterwards, it spits out the exhausted electron after using its energy. The hydrogen that is in the lumen wants to escape the thylakoid membrane. However, the only exit is through the ATP synthase, which in combination with ADP makes 3 ATP molecules for every 14 hydrogen atoms.
Wait, so... Wait. It's just a question. What's the difference between ATP and ADP?
Well, ATP is the charged version of ADP. Think of ATP as a fully charged phone battery, and ADP as a dead one.
Oh, I get it now.
In Photosystem I, yet again the chlorophyll absorbs photons and excites the electrons, passing energy along each other until it reaches P700, where the electron pops off and is taken to a molecule called the NADP plus reductase, which uses that energy in combination with an NADP plus to make another NADPH.
So is like the NADP plus kind of like the ADP?
That's exactly right, Jesse. Hey, maybe I was wrong about you being a complete idiot.
Yeah, maybe I'm not.
Wait, Jesse. Jesse, calm down. You still need to know what happened to the first electron that went to the cytochrome complex.
I don't give a...
Jesse, please. Please.
All right. What happens to the electron?
I'm glad you asked. Well, Jesse, the energy is gone after it gives it to the cytochrome complex, right? So after that, it gets taken to Photosystem I and given back to the P700. Now you have everything you need to make glucose.
Oh, great. It gets back the electron.
In the stroma, the ATP and NADPH are used to create glucose in a process called the Calvin-Benson cycle. An enzyme called ribisco takes a molecule called RuBP and connects it to a CO2 molecule to create a new molecule, which immediately splits into two other molecules called 3-phosphoglycerate. The chemical energy of ATP and NADPH are used to convert the 3-phosphoglycerate into 3-GP, and the leftover NADP plus and ADP are returned to their respective cycles. For every 6 molecules of G3P, 5 are modified into Ruby P and returned to the beginning of the cycle, while the one left is used to create a number of things, including
Will you shut up about the glucose, huh? Why is it so important that I know that photosystems absorb light to energize electrons, which are carried away to do work, and are replaced with other electrons and molecules like NADPH and ATP are used in the Calvin-Benson cycle, which takes CO2 and Ru-BP, whatever that is, and eventually ends up with G3P. And some are sent back into the cycle while one is actually ready to be used.
Jesse, I'm beginning to feel like you aren't taking photosynthesis seriously enough.
Oh, you think? Well, I'm sorry I can't see what's so important about a stupid—
Jesse! You imbecile! Photosynthesis is one of the most important processes to the success of life on Earth. It's why we can live on land and eat these plants and animals. Without it, we won't exist. Period.
Oh, well, if you love photosynthesis so much, why don't you marry it?
Why don't you
are
marry
such a
this?
total a-hole.
Although
I've just
most
spoken
times
enough
the
of
two
your
couldn't
behavior.
see eye to
And
eye,
again, after
their
the
loyalty
work
to each other
you
could
used
make
to
a grown
wait,
man
you're
cry.
a squirrel, and you
Hello,
break everything
I'm-
you've done. Don't
Well,
call
You want to
me.
know something,
You
Jesse?
know who I am.
Come by
I
my
think
house.
you're the stupidest person I've ever met.